Okay, so yesterday we talked about classifying the universe. We classified it into 3 separate groups. Can anyone tell me what one of those groups were?
Matter.
Matter. What was another one? Atoms? Energy. And what was the last one? Aiden.
Horses.
Horses. So we came up with this graphic organizer. Can anyone tell me what the definition of matter is? You guys remembering it now? Okay, everyone stand up. Okay, you guys ready? Matter is anything that has mass and takes up space. So again, matter is anything that has mass and takes up space. Okay, now you guys do it.
Anything that has mass, it takes up space.
Nice job. You guys can go ahead and sit down. Yes, nice job. Okay, so do you guys remember from our activity with the different cards, do you remember seeing the word atoms on one of the cards? Yeah, was that in our matter section? Yes, it was. So that's what we are going to talk about today. Atoms are the smallest particle from which all matter is made up of. So if I take this piece of paper and I cut it in half, and I cut it half again, and keep doing that until cut it in half, cut it in half, cut it in half, I'm going to end up with the tiniest little piece of paper. And that's going to be an atom. Do you have any questions about that?
So how many times did you cut?
I would keep cutting it and cutting it. I wouldn't even be able to see it, technically.
But then you
So you're gonna get to a part where you cut, and like it's gonna be like so tiny that you can't even cut it with the scissors, right?
Yeah.
So like in your mind, like philosophically thinking about this, you would have to like think about how you would cut that tiny, tiny little piece of paper in half again, and then you would cut it even more in half and more in half. And all of this, you'd have to be like envisioning this in your mind until you got to such a tiny, tiny little piece, we wouldn't even be able to identify it as a piece of paper anymore. It would just be a tiny, tiny little atom. And that's what an atom is. It's the smallest piece that we get that makes up matter. Maybe.
have to have like incredibly sharp scissors for that. Like just like not even.
Right, and that's why we said it's kind of in your mind, like philosophically thinking about it. Yeah, kind of imagining it.
So atoms we cannot see with our eyes. Has anyone seen this kind of microscope before? Yeah, this is just a normal light microscope. If we wanted to look at an atom, we still wouldn't be able to see it using this type of microscope. So scientists have to use a very complex microscope. That is called a transmission electron microscope. So they are going to send beams of electrons into an object to form an image. So that's an image right here that they came up with. And it had to magnify it so many times that you can kind of see the individual atoms right here. There's a lot of them right there.
How small is that symbol?
Really small. I don't know measurements.
So the transmission electron microscope actually magnifies things 10 million times what the actual size is. It makes it that much larger. So if you think about, you have a magnifying glass, okay, and you just want to look at something underneath the magnifying glass, take that on steroids, and you get the light microscope. Then take even more steroids, and you get the transmission electron microscope, okay? Grant?
Would you have to be like really very skilled? Because if you put it just like a little bit off, it would be like a mile off, wouldn't it?
Right, so what they actually do, that whole thing in there, they put a specimen in there, and then it's in a vacuum. So there's not even any air present. It's completely vacuumed out, and then they shoot kind of like, you guys can think of it as like a laser beam at it. And then particles will kind of bounce off the specimen, and then the computer analyzes that information and comes up with an image that looks like that. And then we've kind of looked at, even magnified it more to get that one. So you can see all the little tiny circles. That's the best image we can get of an atom with all of our technology.
Do you have any like equipment like that to view items?
That costs $95,000.
Oh, they're not.
I have a question. Why in a vacuum there's no air? Because if you like using like one of the vacuums to like sweep, you like sucking in air.
Different vacuums.
Yeah.
We're sucking out the air in the vacuum that we're using here.
So is atom like a thing, or is it like, or like something with I think that you said that, but like why do you like? Is it in there?
So if you, are you taking up space? Do you have mass? So you are made up of atoms. You have a whole bunch of atoms. Air. Do we figure out that air is matter?
Yes.
So what would air be made up of? The atoms. But they're just so tiny. I mean, so tiny that we don't even, on a daily basis, think of them as existing. They're that tiny. Okay, so, Riley, do you have a question?
No.
No? Okay.
Okay, so we are going to look at a website that's going to compare. Well, we're going to start with something kind of larger, and then we're going to make our way down to an atom.
And wait till you see the item that Miss Sullivan just called large.
Yes. So for this, the large item is a coffee bean or a grain of rice.
Why is
Okay, so in this website, there is going to be a word or a few words that you might think is funny, but you guys are all in 6th grade now, and I think you guys can handle it. So there's actually going to be an egg cell and a sperm cell, and we're going to talk about feces, which is poop. So I'm going to give you guys like 20 seconds just to laugh, let it all out, and
Look at your friends and be weird if you need
make
to.
your funny faces.
If you need to say the word sperm, you can say the word sperm because it's just a scientific term is all it is. If you need to blush, you can blush. Some of you are blushing, that's fine.
Okay, ready, go. Okay, are we good now?
Okay, so how we handle this situation is when we get to these words and we're talking about these things, a lot of times it's just kind of made funny because the society and media has done stuff like that to make you feel embarrassed, but you shouldn't feel embarrassed because it's just part of science, okay? So we're looking at the scientific aspect of everything. If we struggle to be mature about it, how I handle it is you just go sit down outside Mr. Clark's office until we're finished with the conversation, and then you'll be invited back up. In the springtime, when we talk about life science, we are going to talk about some of this stuff. So it's very important that you guys can handle that and be respectful because you don't want to miss out on the content.
Okay, so we're gonna start here with coffee bean and a grain of rice, and those are super tiny, right?
Our measurements, what are we measuring in right now? Millimeters. Okay, so you've been dealing with centimeters. How many centimeters are in the meter stick? Do you remember? Adam? 100. Then, and this is a horrible meter stick to be using right now. The small lines that didn't have numbers, do you know what those small lines represented? Gabby? Millimeters. How many millimeters are in a meter stick? Curtis? 1,000. 1,000. So keep that in mind that those tiny little lines, there's 1,000 of them. Okay.
Okay, so we're gonna start zooming in. You guys know what a Sesame seed is, right?
Think Burger King buns.
And then we're gonna go to a grain of salt. And now we're gonna get into amoebas and paramecium. Those are both living organisms that are super tiny, and they are found in pond water. Yes.
Yeah, James just asked to remember learning about these on the one review game. You had the paramecium. What?
Do they actually
I don't know. I don't know a lot about paramecium. I know you tend to study them a little bit more in high school biology. If we get to the life science, I've actually had pond water come in and we have observed paramecium and amoebas underneath the light microscope in the spring. So we do have light microscopes. Our light microscopes are about $300. They don't work amazingly well, so I usually borrow the high school light microscopes, and those are about like $700 to $900. But they're really cool. They work really well. Nathan?
So when the paramecium be like huge compared to like the animal?
We'll have to wait and find out. We'll see that. So right now, the amoeba and the paramecium, even though we use the light microscope to view them, that's the best way to view them. We can actually see them without a light microscope. But conditions have to be like perfect. It's kind of rare to see them without the light microscope, but we can see them. And if you look, we switched to new measurement.
What is
What do you think that is?
You took it upside down.
Weird looking, huh? It actually stands for micrometer.
Oh,
Right. But we can't use MM as our abbreviation because what does MM stand for?
Millimeter.
Millimeter. So what they used is a Greek letter, and they actually call that mu, like the Pokemon Mew. Okay? So,
Pokemon Go.
Pokemon Red. I'm an original. OG. All the way. Okay? Charmander. Shout out Pokemon people. Okay, so,
Aiden.
what we have, if you've not figured out, I'm a total nerd. I love all things nerdy. I love Pokemon, Star Wars, Star Trek-ish. Star Wars is way better.
And you like Harry Potter.
And Harry Potter, yeah, of course. Okay, so I was meant to stay my entire life in middle school because I love all things at middle school. People love. And pizza rolls. So, okay, so back to our paramecium and our amoebas and our micrometer. There are 1 million micrometers in a meter stick. We can't put that on the meter stick. The lines would be too close, right? So just kind of keep that in mind, that for a micrometer, you would have to fit 1 million lines in this meter stick. Yeah. So the difference is -3. So I think there's 100 micrometers in 1 millimeter. I'm gonna let you guys in on a little secret. I fake how good I am. I'm not good at math.
So
I can't
here.
philosophically think about math things. So usually when you ask me math questions, I take my best guess and then I figure it out after class and then I come back to you and tell you the answer. So
Calculator.
I will offer you a candy challenge.
Ooh.
You can figure out how many micrometers are in a millimeter. You can look it up on Google. You can ask us to sign. You can write it down to figure it out. Nope. Anybody who answers the question on Monday, you have to have it written down, but you have to tell me who your source was or what your source was. How many micrometers are in a millimeter?
I can do it. How many
Okay.
I got it.
You know, we're not looking up now. We're not looking up now. You can write it down, and we're moving on. If you get it right, yes. Okay.
Okay, back up here now. We're gonna zoom in a little bit more, and then we get to our egg cell. And our egg cell is our largest cell in the human body.
Not everyone's gonna have an egg cell though. Only girls are gonna have egg cells. Okay.
Aren't they things that start out in baby?
Yes. Yep. So that's why the females have egg cells and the males have sperm cells. We can still see the egg cell without a light microscope if the conditions are perfect. everything from here on out that we talk, anything smaller than the egg cell, you will not be able to see without the use of some sort of microscope.
And then we have a skin cell here and also a photoreceptor rod. Those are tiny cells that are in our eyes that help us see color.
Oh, so it's very bright color.
Not necessarily. Your rods and cones are what you help you to see black and white and shadows and like colors and things. So if you're colorblind, they might just not work in the correct way. Doesn't mean that you don't have them. In your eye? Do you know what I'm going to do? I told all the other classes this, because you guys will start, we're going to be talking a lot about the human body with a lot of these things. I will put up videos on the link in Google Classroom for the I Love Science wall. And so I will put one up about your eye and how all of your cells work together in your eye and where it's located. There's a really cool video that I actually have on that.
Doesn't the prefix photo mean light?
There you go. Kennedy?
Now that I'm doing all this stuff in my body, I keep on questioning labs. It's so weird.
I know, right? Kind of blows your mind a little bit, doesn't it? Walter? So, you actually have trillions of cells in your body. And there are a whole bunch of different types. You have different types of cells making up your stomach. Your skin itself is made up of trillions of little skin cells all put together. So we can't see the individual cell, but once we get a whole big group of cells together, then we see it and it looks like your skin.
Okay, we're gonna keep moving in.
Oh, nice.
And now we see the sperms up there. And then we have our red blood cell, which is in our blood. And then we have an X chromosome. Yes.
I have for the skin cell.
Yep.
Like when you when you peel off some of your skin and you're able to see it, is that just one cell?
No, that's made up of a bunch of skin cells to make that piece of skin. So our X chromosome holds our DNA, and Baker's yeast. Oh, okay. It does. It helps bread rise. You can
So-
explain your.
Do you guys know who Alton Brown is on Food Network? Anybody watching Food Network? Alton Brown.
No.
You don't watch the Food Network? Okay, so Alton Brown, it's a really cool show. I would highly recommend it. It's called Good Eats. He talks about the science behind food and baking and how to make the perfect food because of like what's going on. Kennedy, you watched it?
Yeah.
So whenever he talks about baker's yeast, he like these little sock puppets come out. And what they do is they gobble up all the sugar. So when you make bread, you have these little packets of yeast, and it's actually like not activated, so it's like the yeast are hibernating. And you pour the yeast into like your sugar and flour and all of that stuff, and then you have to let bread sit for a while in a warm spot. The heat activates the yeast and makes them kind of come out of hibernation, and they eat up all of the sugar. Once they eat the sugar, they are alive.
Ooh.
Once they eat the sugar, they essentially fart and burp gas, which makes bubbles, which causes your bread to rise, and that's why bread has holes in it, because it's the like leftover part of where the bubble of gas is. Pretty much. The gas that they emit though is carbon dioxide. So what we breathe out, that's what they're burping or farting out is carbon dioxide.
Good job.
You know what? I was scared somebody was going to ask me that question because I don't know what happens to the yeast. I don't know if you heat them to a certain part, if they just kind of bake. I don't know. Well, you guys keep going with Miss Sullivan. I'll look that up and I'll be able to tell you before the end of class. But I wondered the same thing because if they're alive, Maybe you guys just bake them to death. You guys are cool people.
Or maybe they make us fry and make us different colors. I eat a lot of bread.
That's not how it works. How would you they're the same size, but it's activated and not activated. Yeah, so the little things that you're seeing is actually like a bunch of yeast that make up that little like pill thing. That's just one of them. Yeah. Yes. Yep. Kennedy?
I can't wait to tell my sister that.
We're eating porky.
Yeah, it's a good story.
You know
Okay, we're gonna keep going.
Okay, we're gonna keep zooming in. We get to E. coli bacteria. Does anyone know what that is?
Oh, I know it. Mine was gone.
Yeah, we learned
What
about
about
that
this
at
one?
some point.
E. coli bacteria.
I've heard of that. It's like a disease thing. I've heard of E. coli. Like coli.
So this is actually found in feces, which that's
Okay. Well,
so when you guys go to the bathroom, that's why everyone tells you you need to wash your hands after you go to the bathroom because you don't want to get this bacteria all over your hands and then go and eat a sandwich.
I don't think I'm eating
Okay. So then right here is mitochondria and a lysosome. Those are both inside of a cell. So
Oh, now it's getting
okay, so the way Mr. Schaefer explained this to the other classes was you have a watch. Let me see. You have a watch, and you know how you open up the back and there's all the gears and the batteries and all that? So the watch is a cell, and inside of it is all these different parts that work together to make that cell function. So these two would be parts of the cell. Does that make a little more sense? Okay, so we're going to keep zooming in.
Oh, it's not really.
Okay, so we're to a different measurement now. We're at nanometers. So there's a billion lines or tips.
Billion, yeah. We'd have to put a billion in this space.
A billion's a number.
You would never see that.
Right, we wouldn't see the lines, and that's why we don't see these items without, at this point, we're past using a light microscope. At this point, we're having to use the electron microscope. I'm going to post an image over real fast.
Okay.
Did you talk about the viruses?
Nope, not yet.
Okay, once you talk about the viruses, let me know and I'll pull the image over.
Okay, so the measles virus is something that we can usually get a vaccine for. And HIV is another virus. Influenza virus, that's just the flu. Yeah, that's no fun. And then this one up here is bacteria. Phage.
Hey.
And then this vesicle up here, that's another thing that's going to go inside of the cell. Jackson.
Wait, do viruses float around in the air? Is that how they get to people?
Yes.
So how a virus works. This is actually, I want to show you, I found an image of virus under an electron microscope.
Get them away. See, I'm touching. He's touching me.
I haven't flinched now, I'll tell you that.
Oh.
What's that?
So if we were to take, say somebody who's sick, certain viruses are transmitted different ways. Some viruses can only be transmitted through bodily fluids. So that would mean like blood, if somebody else's blood gets into one of your cuts. So like the HIV virus, did we get there yet?
Yeah.
Yes.
The HIV virus can be passed between blood that way. That's why nurses and doctors, it's always important to make sure that they're covered, not only to protect you, but to protect them as well. Because they don't want to get your blood into their body. Also, the other way that can be is like through spit, so kissing, or if you were to sneeze and then sneeze onto like a surface, that and it stays wet and then somebody touches it, or you sneeze onto somebody else, it's passed through liquids. The really contagious viruses can be passed through the air and don't need to be in any sort of liquid. So what you have to think about, this is what they look like. So if somebody would like sneeze onto a microscope slide or whatever slide they capture there for the electron microscope, and then they use that in the electron microscope, that's what they look like. So you can kind of see the resemblance to the pictures that we took. Now, I was looking up information on yeast. What viruses have you talked about so far?
Those.
Have you talked about all of them?
Yeah.
Not hepatitis.
No.
Okay, so let's zoom in a little bit farther.
Rhinovirus.
Does anyone know what rhinovirus is?
You turn into a rhino, obviously.
No.
Yes.
Oh,
What'd you say?
Jackson.
It's a specific thing that animals get.
No.
No.
Nathan?
I'm just guessing this, and don't blame me for my stupid.
Yep, that's alright.
But I'm just guessing that you grow apart.
Not quite.
That would be pretty scary. Nope, not right. Should we tell them?
no, please
No.
don't.
Don't
If
tell
it's
me.
disgusting.
Actually, the common cold.
Oh.
Wait, can we get it from
Okay. So this is how the rhinovirus works. The rhinovirus, when you sneeze, okay, the reason why the rhinovirus is so commonly passed along is because it doesn't have to like stay in liquid. It's not passed that way. So you could sneeze, and when you sneeze, and if you have the virus in you, it's going to get sprayed out as well. We don't know how viruses first originated. We don't have scientific proof of how viruses first originated. What we know, though, is that they're all around and they just kind of happen. If it gets into your body, it's going to start to replicate itself. You guys studied parasitic relationships in elementary school, right?
Yeah.
So a parasite has to have a host to live on. Scientists can't agree if viruses are a living thing or a not living thing, because without something to live on, they die. Some viruses can last for weeks. Other viruses can only last for seconds in outside of the environment that they need.
So why did they tell you to sneeze like this? Then they're just giving your virus back to you.
Well, but here's what happens.
Like sneezing on
Okay, so let's follow this pathway. This is what happens. Somebody sneezes and doesn't cover up their mouth. That goes into the air, and one of those virus things makes it into Carson. It starts to reproduce. Carson, his immune system is going to start fighting off the virus. Sometimes your immune system works and fights it off so well that you don't even recognize that you are exposed to the virus and you don't get sick. If you get a fever, that's the sign that your body is actually trying. It's like in the middle of the war. And the fever is elevating it because it's really working hard to fight it off. If your body can't fight off the virus, then that's when you really start to get the illness and the symptoms and everything. Some viruses can kill you if your body doesn't fight it off. Influenza, back in the early 1900s, there was the Spanish flu. It was a form of this virus, and it was an epidemic. People died from that virus because their immune systems couldn't fight it off. We now have a flu vaccine that you can get. They guess, though, on what type of virus it's going to be. Because the influenza virus, it is very smart. It changes. And so the scientists have to try and hypothesize what virus it's going to be or predict what virus it's going to be for that year, and that's the vaccine that you can get.
So sneezing on my sister was not a good idea, is
Yeah,
it?
it's not a good idea. That's how you pass along. If your immune system, though, has already fought off that virus, and it has those antibodies already created, then a lot of times you won't reinfect yourself. So that's why we say like sneeze it there because it's containing it. And by sneezing here, people don't typically touch you on this part of your arm. Unless you're
Unless you're doing
Unless you're going to prom.
Oh, okay.
Is there like, is there like, it's kind of hard to explain, but is there like some viruses that go kind of stay, well, it's like, it's kind of hard to explain.
What's difficult with viruses is the fact that all of these viruses are also different and your body reacts in such different ways and gives you different symptoms. It's really hard to talk about viruses in general. So that's why it's cool if you get a chance or you have free time. You can either watch, I'll put a video out there about viruses and how your body responds and what your immune system does. And then you can also read about different types of viruses.
why do people like when they're saving money look at shoes?
I don't know. That's a good question. Okay, so here's the thing. We have too many questions and we're going to run out of time. So if you have your question, write it down on a sheet of notebook paper. Okay, so if we don't get to you with your question, write it down and then I'll look up answers or post videos on Google Classroom for you guys to watch when you have free time. We are moving on.
When can we turn in our sheets of paper for the, like,
Monday morning.
Okay, so hepatitis virus is another virus that we have vaccines for, which we kind of talked about. So then we get into this one. A ribosome is also another thing that goes inside of the cell. Hemoglobin is part of the blood. Antibodies, which Mr. Schaefer just kind of talked about, that those help fight off the viruses that are in our bodies. RNA is a part of our DNA. Phospholipids, zoom in a little bit. Oops. Those are fats. And then that leaves us with these right here. These are all different molecules, which is a bunch of atoms bonded together to make that molecule.
Anywhere from 2 atoms to you might have like glucose and methionine and adenine. They're called micromolecules, and that's going to be really large molecules. So you might have hundreds of atoms put together to make that.
we only have one out.
Lucy, are you noticing something?
Yeah, glucose,
Methionine,
methionine, and I think
adenine,
and adenine are sugars, right?
glucose.
Yeah,
sugar.
glucose is sugar. I know that.
We have a new measurement.
Yeah.
PM. We're at the picometer. You now have to fit a trillion on this dish. Okay?
I wish we had money.
Adam, is like iodine part of iodine?
Iodine is not. Iodine is a chemical. Iodine, I'm not going to tell you too much about iodine. You'll get to explore it probably like end of next week, maybe.
Oh, cool.
Oh, cool.
Yeah, at the rate that our lesson plans are going, we might never get to iodine, but no. Probably end of next week or beginning of the following week.
Yeah,
My mom was a helper, I guess, and I learned a lot about iodine, but I know it, but it's kind of, it's like, I know it, but I don't. Like,
Right. A lot of things that we interact with, you guys are going to know at like the large level. We're going to start studying the molecular level, so looking at the molecules of it, and the atomic level, and studying the atoms of it. So we're going to go super small.
Okay, we're going to zoom in a little bit more. And we have our single carbon atom. Does anyone see something between these two? Like what's different between those? Riley?
The water molecule looks the exact same, but looks a little smaller.
It does look smaller. So our carbon atom looks bigger, so not all atoms are going to be the same size. What else?
I don't know if I'm seeing this correctly. Okay. So the carbon looks like they're compressed together.
So our carbon atom is just one atom together. Our molecule has multiple atoms, so that's why that one looks a little bit
Is there anything,
different.
is there anything less than that?
Nope.
So the carbon atom, that not only Ms. Sullivan said that shows us that atoms are going to be different sizes, but by giving it the name carbon atom, that tells us that there's going to be a lot of different types of atoms. And next week you're going to get to explore all of the different types of atoms as well. Why do you think they chose carbon atom? Because the water molecule is made out of 1 oxygen atom and 2 hydrogen atoms. So why randomly did they choose carbon? Walter? Okay, so it's making up carbon dioxide. That might be a reason, but did we talk about carbon dioxide? No, it's not. Okay. Adam?
It's not part of water.
It's not part of water. But why not choose another atom that's not part of the water molecule? Like, why not choose a gold atom? Everybody loves gold.
Where this is
Is that
gold,
real?
There is such a thing as a gold atom.
like in gold nuggets.
Yep, they make up gold nuggets. Lucy?
Because carbon is air, isn't it?
Carbon atoms aren't floating around in air by itself. They're floating around with oxygen atoms that make up carbon dioxide. What was this whole thing like? What did you notice about a lot of the other items in this that we like zoomed past? Curtis?
They were in your body.
And our body is,
Made up of atoms.
and we are what?
Matter.
Living.
Yeah.
Carbon atoms are in every living thing. So there are going to be a lot of carbon atoms in our world. Not just one carbon atom. You're going to have a ton of carbon atoms. If you want to do anything to be like being a doctor, you're going to have to take something called organic chemistry, and it's all about how carbon atoms act. It's all carbon. Okay, so carbon is the main atom in living things. We see it a lot.
This is about the third year.
Mhm.
Well, we do that.
We do not play sex in 6th grade. I know.
Is there anything smaller like water atoms or
We'll have to wait till next time. Until next week.
I have a question that I like literally.
Okay, Lucy kind of brought up a point too. Forgot to talk about this in 6th grade. Atoms make up us. We are living. Are atoms living?
Yes, he's right there.
They don't know.
Yes,
No,
you
I don't think you're not.
Is this desk made up of atoms?
Yes. No.
Is the, okay, let's rewind. Atoms make up what? Matter. Atoms make up matter. Is this desk matter?
Yes.
So would this desk be made up of atoms?
Yes.
Is this desk living?
No.
So would the atoms making it up be living?
No.
Yes.
No. How could a living thing make up a non-living thing? That would not work.
Like
So
I
no.
couldn't be a dentist.
What?
I couldn't be a dentist.
Now, are you matter?
Yes.
Are you living?
Yes.
Are atoms making up you?
Yes.
Are atoms living?
Yes.
Are
certain atoms because they're attached to your body.
Atoms are not living.
Yes.
But then
That's what's weird. That's the crazy mystery of life. We have non-living things building up, and something happens to make us be living. That's what's weird. And at this stage of the game, I know, at this stage of the game, we're just going to accept it. That atoms are not living, but cells are living. And somehow that has happened. Grant?
like a flower, it would be living when you give
Yep.
it all the things, but then if you stop giving it those things, it's not living anymore, is it?
It's dead.
Just like
So that becomes a question of not living ever, living or dead.
So if you don't give us food, then we
Okay, we're gonna hold the questions for 1 minute because 4th period really wanted to do this and it was kind of cool. They asked if we could zoom out.
Yeah.
Yeah.
it's kind of like your hair.
He's like,
Oh, it's so low. I'm watching.
the carbon atom is just like, until you can't really hear it.
Still can see it.
We're not even to the things that we can see with a light microscope yet.
And you can't see it.
Wait, what would you use to see an atom though?
An electron remember the electron microscope that Miss Sullivan showed at the beginning of the class?
Okay.
You can like not see
Now we're to light microscopes and not light microscopes.
The grain of salt would be like 1 billion times more than.
That's kind of weird. Salt is
What?
bad.
You want? Anna asked if we could do it fast.
Oh, go back.
Okay.
Whoa.
So that was too fast.
Now out.
Now,
You know what this reminds me of? Ant-Man.
What?
You're like Ant-Man.
Now we need like
I'm gonna be sick.
This is a lot of information.
Okay, so that leads us
My brain is not.
to a grain of sand. How many atoms do you think is in one tiny grain of sand?
Like a bajillion.
It has to be an actual number. Aiden? 1 billion?
There's gonna be a million. What's your name? Google.
Okay, one more. Curtis.
Oh.
Oh, I mean Grant. Sorry.
One less than infinity.
That's not a real number. You have to be able to name it.
Yep. Madeline? $5 million?
We're not quite billion. 2.
7.
I was gonna say
No, wait, just put add half of those. You can't just type in
A trillion? Is that what we? Okay. Okay, so we have 1 billion.
I feel like we're running
Okay, wait.
close.
That many. That is.
That's a lot of atoms. 783 trillion atoms. No. Billion.
Okay, we'll get.
We're gonna leave you with this thought,
Yeah.
and on Monday we will talk about more items and how many atoms are making up other items as well.
You want this?
Yes, if you have questions, put them in the top last bit. How many microscopes are in 1 billion?
I'm like you, I'm a nerd. I like the old classic games like Galaga, Pac-Man.
Nice. See?
Cool. How many guesses do we get? If you like,
You have to look it up and write down your source.
what other guesses?
Only one.
If you like pizza rolls, you should meet Bus Driver Aaron.
Really? Does he like pizza rolls too?
Yeah. He said if he ever rented a bus, he'd put